it's recording.
Okay.
Yeah, this is fine. I just didn't see if you really
Yeah.
need to.
Okay.
Sorry.
Any questions so far? So basically, this is what we are going to do: render the same thing with different materials and render one effect for different meshes. Okay. So, and the third reason to me is that this basically is free, so you don't need to any license or you don't need to do any spend some money for that. And then we are going to focus on how to use the Blender's Python interface to render image. Basically, it is exactly the same as writing a regular Python script and using the library, like Blender library, basically. Just like import NumPy, you import a Blender library called BPY. And then that's basically it. And okay, so the outline of today's discussion is that the first, I'll go through the pipeline required to render an image, and then I'll talk about some minimum introduction for the Blender UI. I feel like a lot of people here probably have some experience in Blender, but so probably this will be slightly boring, but there are minimum amount of UI you need to know in order to use the script. So I will talk about the minimum amount of the UI here, and then we'll do a demo. Basically, you guys can try to render an image with different materials, and I can help you if you have any questions through the demo. And then we'll talk about some advanced things if we have time. So first, hope you guys have downloaded Blender 2.8. And just to make it clear, Blender 2.8 is very different from Blender 2.79. It's like a huge revolution for Blender. So you must download Blender 2.8. If not, then you won't be able to use the script. And the script is in this GitHub. And make sure you can run Blender from a terminal, because sometimes you need to set an alias in the terminal so that you can run Blender in terminal, and that's very convenient. And so each script, basically the input is a mesh, and probably some other information, for example the texture image of the shape, and then this Blender script will output a .blend file and .png file. The .blend file is the file that can open using the Blender software, so you can tweak some parameters in the UI. And then PNG, just the image, the rendered image out of it. So first, just go through all the pipeline, and I encourage you guys to open the file tutorial.py there, because I basically put all the comments there in that tutorial, so it would be nice to can hear and then see the tutorial py as a reference. So let me just go. So basically, this script is just first initialize the Blender. I'll go back and forth between the tutorial py and then the slides. So first, if you look at this section, initialize Blender, basically this section, let me make it bigger. This section basically set the image resolution, like the image resolution X and image resolution Y, and this usually I'll set more than 2000 for paper renderings. If you want the paper to be able to zoom in to a specific figure and see very sharp edges, not the blurry edges, you need to set the resolution to be very high, but it will make your paper very big. And the number of samples is because the Blender, I'm using Cycle, by the way, which is like multi-color sampling, and this number of samples basically determines how much sample you want to sample for each pixels. And if the sample is very low, like the 50 is very low, you'll get a noisy image. So if you want to render a paper, basically like more than 200 or 300, I would say it should be sufficient. But if you want to render something that has very high frequency detail on the surface, so for example, very detailed texture, or render an edge that you want to be very sharp, then probably you need to make it even more. But the bigger, the higher the quality, but it will take longer to render an image. And the exposure here is just the exposure of the entire image. If you want to make the image brighter, then you just increase the exposure. And that's just initialize the Blender, some kind of rendering setups here. And the second step is just to render the mesh. It's just read the mesh. So basically, this is passed to the mesh, and currently I only have the option of reading the PLY and reading the OBJ. And it'd be nice if if you have other format, and then write a script to read those format. And I'll talk about how can we generate our own scripts later. And so for each mesh, what we take is the location of the mesh, basically where this mesh sits in the scene, and then the rotation basically determines the orientation of the shape. And the scale, basically you can scale up and scale down for the entire shape. And then I'll talk about where you can adjust these things later in the UI, when we talk about the UI. And then once we read the mesh, and the next thing is to set the shading. I assume like everyone here knows a little bit about introduction to computer graphics, so you must know the difference between like ground shading or flash shading. And this is basically what it does. Basically, if you want the mesh to look to the color to interpolate within a face, then you need to set the smooth shading. And if you want to see the triangle exactly on the rendered image, then you can set it to flash shading. Basically, on command this, it will be flash shading. And then another thing is the edge normal. This is useful if you want to do if you are doing research on, for example, developable surfaces. You want to smooth things everywhere, but for sharp creases, you want to make it sharp. So edge normal basically set an angle threshold here. So this is just a threshold control where you want to have the threshold for having a crease. So if you want to render developable surfaces, you can adjust the angle here so that you can look like a ground shading everywhere except the creases. So that's just the effect of different shading. And this is a subdivision. Basically, if we want to render a shape, we will usually apply subdivision to make it smoother, to make it look better. But if your shape has sharp edges, you don't want to destroy it, then you won't apply subdivision. So you can just set the level to be 0 or comment out this line. And another scenario where you don't want subdivision is in the case when you want to render the edge of a mesh. Like if you want to render the mesh with edges, if you apply subdivision, basically the mesh get denser, so you will render more edges than you expected. So this is just some warning when you want to apply the subdivision. But usually, if you just render, for example, the geometry like this, usually you can apply subdivision. Okay, now this is the most important part. This, I make it like a lot of this thing is because this is the place where you set up the material of your mesh. So basically, if you want to achieve the effect like this, like all the cows are the same for all the other parameters, the only difference is in this section. Basically, this section determines the material of the shape. If you want to render point cloud, you need to switch to point cloud. If you want to render a texture, you want to switch to textures. And all the materials you can find in all the demo scripts here. So for instance, if you want to render a glass material, and you just go through this material and copy paste in this tutorial section here, and you will be able to render a glass material count. So that's just how this section works. Like basically, once you read the mesh, if you want to render different appearance, you just set a different material, and all the materials are in different demo scripts. You can just copy paste into this tutorial script.
So are these your demo scripts? Like, did you write the materials?
Yeah. And if you by looking at the words, if it's not clear how to produce, you can go to the result folder, which shows the rendering of all the materials. Then you can pick one you like and then just copy paste there. Oh, by the way, this is the effect of using edge normal. You can see it's smooth everywhere except the creases. So this part, the effect of edge normal. Yeah. Okay. So far so good. Okay. So once you set the material, you are done with everything on the mesh. Basically, once you read the mesh, just set up a shading to decide whether you want to do subdivision and set up your favorite material, and the rest of it just like some environment settings. So first, the invisible ground, as I named it, it's the technical term. It's called the shadow catcher. Basically, in this figures, you can look at that. Let me make it. Wait a second. So if you look at the shadow here, it's like a transparent. It's like transparent shadow, right? You can see like you can still see the white cow underneath because the shadow is transparent. And personally, I like this in the paper. I want the shadow to be transparent. So if you want to put multiple images together, you won't influenced by the white background that you may kind of overlap on other images. So this shadow, this invisible ground basically is just a plane in the Blender UI. And if you render it, this won't appear in your rendered image, but it will capture the shadow and then display shadow in your rendered image. So this is just like always there if you want to have a transparent shadow. And then there's a parameter brightness, basically control the brightness of the shadow. If you want the shadow to be darker, you decrease the value. If you want the shadow to be like lighter, you increase the value. And another thing, the next thing is to set up the camera, basically where you want to take a picture of that shape in the scene. And I prefer to use the camera location, basically between the location of the camera and look at the location here. You can look at 0, 0, 0, basically look at the center of the scene. And focal length is just how much zoom in you want to do in your camera. So if you increase the focal length, basically just zoom into your mesh. If you decrease it, just like zoom out. And like in practice, I won't recommend you to modify the camera because placing the location and the look at is kind of more hard. It's harder to adjust because it's the same as you move the mesh and move the camera because they are relative to each other. So in practice, I feel it is easier to move the mesh instead of move the camera. Unless you want to adjust the elevation, basically how high your camera is and look at the location. If you want to look at the mesh from a top-down view, probably you can increase the third value of the camera location. Basically, it's the elevation of the camera to very high, then you can look a mesh from a very top-down view. And you can decrease it when you want to look at it from the flat view. But usually, that's the only thing I will adjust, or the look at location I will adjust. And if I don't feel my mesh is at the right position, I will adjust the mesh instead of just the camera. And I'll talk about how to adjust those parameters in the UI later. But here is just the camera. Oh, by the way, for the scripts, if you look at those scripts such as this line, I have a UI dot, and this basically shows where you can find this parameter in the UI. So I feel like this is useful to remind me where is the parameter. Okay, and the next is the lighting in the scene. And currently I have two types of light in the script. The first is the 3-point light. I think it's a very famous lighting setup. Basically, it's a setup with 3-point light. Usually that's probably the default lighting setup if you want to, for example, render a face of a human, something like that. So it will. Let me just show you the effect of those. So if you look at this 3-point light, this will produce. Probably it's better to look at. Okay, because it's a gray background. Let me paste it here. So this is the effect of using 3-point light. Basically, it produces those like transparent, nicely blurred shadows to your scene. And the other option is to use sunlight. If you use sunlight, single color, this is what you will get. You'll get a darker shadow, but because sunlight is just a directional light. So I think it's just a personal choice, depends on which one you want. But basically you have two options for the lighting here. And the one's the 3-point light, and the other one is just the sunlight, which correspond to these lines. Yes?
Is there a way to do environment lighting with your?
Oh, I haven't had that feature. That's on my to-do list.
Okay.
Yeah, that's a good question. So yeah, this is the current lighting setup. I will add the environment light.
Don't you have to have environment for glass and stuff? Like, don't you need environment for glass? If you're on a longer glass, that looks nice.
Yeah, if you have rendered that metallic shape, it would be better to use environment light so that you can reflect the scene. But currently, I didn't render metallic surface that much, so I didn't think of using an environment light. Typically, I'll just render the smooth, diffuse shading, like the blue color. Yeah.
Sorry. One thing that happens often to me with your toolbox, and I don't know if it has a solution or not, is I want to do everything that you're doing and then just one small thing that is not supported. Like, for instance, can I load a blend file that just has the environment lighting and then run all of that and render?
I will talk about how you can write your own script at the end of the discussion. Then you're able to add your you're able to add your own script that satisfy what you want to achieve, like on your own.
Yeah, no, but I don't know how to script it, what I want.
Yes, that's why I want to talk about how you can script it.
Oh.
Yes.
Okay.
So it's better to teach you how to get the fish.
Okay.
Yes. Okay, so here are some parameters for the 3-point light, and then here are some parameters for the sunlight. And in terms of the time, I don't think it's worth going through the parameters. But if you're interested in, we can talk about it offline. But basically, I have two lighting conditions you can set, and also the ambient light. Ambient light basically is similar to the exposure. It just like increase the brightness of the entire environment. So, and this is the color. And by the way, the color in Blender has 4 values because it's like R, G, B, and alpha. So usually like it's 4 values here. Okay, and now we are nearly the end of the script. And this thing is just like I prefer to have, and thanks for that. Basically, this is like the threshold that can make the very like light gray shadow to be completely white. And you can control the darkness of the threshold, like using this alpha threshold. So you set it higher, then you'll remove like darker shadows. You'll make darker shadows into completely white. If you set it to be very low, it only makes the very light shadows to be completely white. So this is just something I like to have. And then these 2 lines basically save a Blender file named test. You can save it to different names, and then render image. So for now, let me see what's my overview. Okay, so now we have go through all the pipelines here. Basically, this is just what we just go through. And then if you are lazy, you don't want to tune so many parameters, these are the thing probably you will need to adjust if you don't want to adjust so many parameters, but these are the thing you want to adjust. Like you want to at least load which mesh you need to control, which mesh you want to load, and then set up the shading, set up your desired material, and then maybe control the camera elevation, and then set up the lighting, because sometimes if your light is not in a good position, you need to change it. But if the default lighting you like it, then you don't need to change it. Basically, these are the minimum amount of things I'll typically adjust for each time I render a mesh. Okay, so now let's try to run the script. If you guys have downloaded and then be able to run the Blender file, open your terminal and let's make it bigger. And now I'm in my cycles, in the Blender Toolbox cycles. If you're in this folder, then you can just run not python.the-demo, because like I know that the straightforward thing is to run Python space demo whatever, but here you need to use Blender to run that file. So you need to type Blender and -- background, and this command basically says that I want to run Blender in background. I don't want to open the Blender for me. I don't want to open Blender when I render this. So only run the Blender in the background. And then Python, and then -- Python basically tells you this is a Python script. That's it. And we can run our tutorial.py. And once we do this and click enter, then it will run the mesh for you. And and once it is done, you will be able to see in your, I set the default path to be the result tutorial PNG. So if you go to your results, you will find the tutorial PNG, and that is basically the render image of that script. And that's how simple it is. If you want to render an image, just run a terminal like that. And this is very handy if you want to render a lot of images, and you basically just can create a batch file, render everything. And it is also good if you can save this script. And if you want, because save the script has a benefit that if you want to render some mesh in your paper, but probably after a few weeks, you update the algorithm so the result change a little bit. But if you want to update the figure of your paper, you don't need to adjust the parameter at all. You can just replace the mesh and then run the script again, and you will get the updated image. And another handy thing to use this is that you can render it on server pretty easily. You don't need to mess with the interface on the server. You can just run the script on the server, and then you'll get the result. So that's the thing I found it very useful to me. Okay, so any question? Can you guys run the script?
I cannot, yeah. I get the center, no module named include.
Did you change your path? Go to the Python. You open up the tutorial file. It's a hard code.
Yeah, there.
Oh yeah, yes. But, in tutorial you need to append the path to the Blender bar.
Oh, I see.
Uh,
Okay.
Is there a way to just for it to detect that the include.py is in the same directory and use that? I've been trying to look into doing that.
What?
Oh, is there a way to not add it to the path directly? Because it's in the same directory, right? It seems like it should be.
Oh, but yes, but you don't want to go to this directly every time. You want to copy this tutorial PI to somewhere else where you are mesh listing and render there. Is that right?
Oh yeah, but then yeah. Okay,
So that's basically the reason of set it as a default, because so for instance I will have for example I will have render figure code here, and then for each thing I have a render py, and this is basically the render image of that mesh. And I probably want to put it somewhere else outside the toolbox, then you need to append the system path.
right.
Yes.
That makes sense.
Yeah. And because it's not just a Python script, so if you want to render entire folder or render entire animated mesh, a bunch of 100 meshes, and then in sequence, you can also use the Python to for loop or everything, and basically all these things will be inside the for loop, and you can render a sequence of mesh very easily. Okay, so now that's once we know how to run the script, but now we haven't talked about how to adjust the mesh, what's the Blender UI, right? So let's have a minimum introduction of the UI so that you know how you can adjust the parameters shown here, like the shading or the position of the mesh or the lighting. Okay, so now if you run this script successfully, you'll be able to see a test Blender here in your cycle folder, because that's where we save it. You can also save it to somewhere else. But when you open your cycle folder, this is basically when you double click it, this is a Blender UI you will see. So this is this is a mesh, and this is your camera, and this is the lighting. And here I'm using the 3-point light, so I have 3 light sources, but this just it may different if you have sunlight. So if you want to adjust the position of the mesh, you move your mouse to the top left. There's a small arrow here. Do you see? And if you click it and drag it towards the left, you'll see, oh, there's a hidden UI here. And then this Blender has so many hidden thing, but this is just the handy UI if you want to adjust the mesh. So if you click the mesh and then see the hidden UI here, can everyone find it? Okay, then this is the location XYZ, rotation XYZ, scale XYZ. These are the parameters you type in your script. Let me just make it. Okay. So if you look at your script, this is location x, y, z, rotation x, y, z, scale x, y, z. This is exactly the parameter you see here. So for instance, if you want to move the mesh, like move like that and move like that, and once you decide, oh, this is great, then you're typing the new parameter in your script, then you'll get your update. But the thing you found it slightly annoying is that if you move the mesh here, you don't know what the camera sees according in this updated location, right? So if you go to probably view here and camera here and set the view camera should be active camera, and you'll see a square appear. Can anyone find this?
You can also click the camera button beside the pan hand. So there's like the XYZ.
Where is that?
Just
To the right.
To the right, just right to you, right? No, to the
No,
left
no,
now.
no, no.
Okay, go. There's the XYZ like coordinates. Now to the left of that.
Oh.
There, you just click that. There you
Okay. Oh, that's even better. Thank you. And because I set up the shortcut, I just click 0. So I never know the button, but this is great. Okay, so if you click this, or you can set up some shortcuts, and this basically sees what camera sees. So you can basically adjust the mesh position, adjust here, and adjust here, like can basically do whatever you like. And this is invisible ground, so you will see that is this ground, but it's invisible. But if you like penetrate it, you will still see the shading becomes a little bit weird in your rendering. So that's basically it. And if you like the new parameter, all you need to do is just remember those parameters and type in here exactly as it appears on the UI, and you get the updated mesh position. Okay, so far so good. And this is how we adjust the mesh. Okay, I haven't talked about material. I'll talk about it later. No, I promise. And the other thing is to set up the lighting here. So, lighting is the same. But let me just, sorry, forgive me. Let me run the sunlight version because this has less parameter to adjust. So I'll run the sunlight version again. By the way, I'll comment out the render image so that it won't take too much time to compute the rendering. So if I just run it again, and I'll just refresh this Blender.
So Blender doesn't lock the file. You can regenerate it while it's open.
Yes. So if you can keep it open like right now, and then rerun the script to update the Blender, and you can, I think something here revert, or yeah, it should be revert. Yes. If you click the revert, and it will reload the script, and then basically it's the new updated parameter. And here you will see this weird line, right? And this is basically the direction of the sunlight. So here I didn't do anything special. I just comment out the script of setting 3-point lights, and turn on the sunlight, and there's a sunlight appear here. Oh, by the way, I default position to set it to be like in the 0, 0, 0, so it's here, but you can move it here. It doesn't appear rendering appearance because it's sunlight. So you can move it upward like that. This is the light. And then it is the same as you adjust the mesh. Basically, if you click the mesh, this is the location, rotation, and scaling for the mesh. If you click the lights, and this is the rotation. Because the location of sunlight doesn't matter, it's just directional light for the entire thing. What matters is the rotation. And if you have new rotation, you can just type in the parameter here, like the lighting angles, and you'll get an updated sunlight. And another thing is that when you want to render something, it would be nice to see a quick preview instead of go back and forth between rendering and wait for like 30 seconds to see the view, to see the rendering, and then go back to adjust your parameters. You want to go through this process back and forth. So in Blender, if you go to your top right in the UI, there's this sphere with like shadows here. If you click here, this basically is a quick preview of your rendering. And if you follow Josh's suggestion, go to the camera, then you'll be able to see the preview of the rendering under all of your settings. And this will be noisy because it's just a preview, so it uses less, it basically is an approximation of the final rendering, but it's a very close approximation. You will be able to see the effect of it. And then basically now, if I have the lighting here, if I change the rotation, you can see the shadow changes. And I can adjust it so that you can adjust the lighting parameter interactively in this UI. And once you love this, you can just remember those numbers and type in here. That's it. And any questions so far? Okay, so now this is a minimum introduction of the UI, and I think that's all you need in order to render an image. And so now I would encourage you, we haven't talked about the material, but I would encourage you guys to just replace this material to something you like, or even replace the mesh to something you want to render, and go through the rendering process. Once we can take a 5 minutes demo break that everyone can try out the script, and then let me know if you have any questions. I hope I covered the essential things for you guys to render, so I hope you guys can spend some time, try to render something you want to render, probably switch to different materials, and then let me know if you have any questions.
So can
Yes.
you talk a bit about the isoline rendering? Like, how do you feed the function?
The function you need to, I'm generally using MATLAB. I can talk about it later, but basically I do it using textures. So basically the UV mesh is like the vertex coordinate with function and 0. So the UV is like a function value and 0. And then base that function value is normalized to 0 and 1. So if you render a stripe texture image with slices there, it will create an isoline.
I see.
Yeah.
So you have one of the materials as texture?
So let me show very quick. So if you look at this mesh, I have a function as UV mesh, and this basically is a function where let me just scroll down. So where the VT, if you see the texture, is just a real value with 0, and basically the texture image is this stripe.
Yeah.
Is this stripe. So if you look at the cycles demo ISO line, then you'll see that we read the mesh that with UV function as UV, and then basically we set the texture using the texture rendering, and then you load that stripe as your texture image. So
Thanks.
no problem. Any questions?
How do you do the alpha threshold thing in the UI?
Oh, alpha. This needs to talk about the shader now. Yeah, I'll talk about it later. I just put the complicated things at the end, but yeah, because shader nodes is like pain in the ass. There's so many parameters to adjust. So, hey guys, any questions to you on this?
And arrows and support
How you run it? Oh, background we meant to do dash Python.
Oh,
So Blender you run, and then background and dash Python.
thank you.
Yeah, and you'll be able to run it. Yes. Okay. So, okay, can I move on, or you still need some time? Okay. Done. Okay, so now let's go through some advanced stuff. Basically, the most important thing is about the material. So right now, you probably know how can we just copy paste materials from the other scripts, and there are different parameters for different materials. For instance, if you want to in tutorial, if you want to render a single color of the mesh as a single color, basically you can adjust the RGBA of your color, and then I have a class for the color object, and here's like the RGBA with hue, saturation, value, brightness, contrast. And then you can also set ambient occlusion. Basically, I didn't go through each material individually because each one has different parameters. But I'm going to talk about how you can see those parameters in the UI. So if you have the Blender script open with a UI opened, if you click the mesh, and if you on top, there's a button called shading. If you click this, you'll go to a different like interface, slightly different interface, and that's the shader nodes. And this is more complicated. If you want to like just render a simple mesh, you don't need to know this. But if you want to really play with the materials, play with the parameters, you need to know. Yes.
Derek, you did this on a MacBook, right?
Yeah.
How is it possible that your rendering is like 1,000 times faster than my MacBook?
What version?
Which method you run? Which you run tutorial?
Sorry?
You run tutorial or you
Just
run
in general, I'm saying like.
in general? Probably that's because the mesh, the image resolution and the number of samples used is much higher than I.
So can I see what you're?
I'm currently running because for efficiency, I'm using both 480, which is a very low res image, and 50 samples is very low number of samples. If you want to render like paper figure, I will recommend to increase this a lot. So this is just for showing the demo, so I make it very small. Yeah, and so this is the interface of your material parameter, and there are different nodes set up. This is called nodes. Each one is called a node setup for the different materials. But here you can, if you click this shader nodes, I try my best to make it easier. So I move. So here's like a bunch of shader nodes like mix up each other here. And this is something you don't need to adjust. All you need to adjust are the parameters I ported out on the side. So for instance, here is the hue saturation value, and then the brightness and contrast of your color, and this is RGB value. So for instance, if you want to make the RGB value, for example, this higher, then you'll see your mesh appearance changes. And this is the new RGBA you want typing in your script. So you can play with the material parameters in the shader nodes, in the shading nodes. And then you can also adjust the brightness and contrast. For example, I want to make it very bright. I want to make it strongly contrast. Then you can adjust these parameters and typing here, like the RGBA, hue, saturation, value, brightness, contrast. That's it. And then this is gamma. It basically controls the ambient occlusion. And yeah, if you don't know what's ambient occlusion, I encourage you to Google online. That's a very nice thing to make the rendering beautiful. Okay, so and then basically there are different nodes set up for different material. I won't go through them all, but I try my best to put the parameters on the side so you know which one you can adjust, which one corresponds to which. Okay, that's the shader nodes. Any questions for the shader nodes?
So just to understand, so basically the Blender shading node is something very complicated, and you generated your own nodes with like simple names that you adjust from the script.
Yes.
Yeah.
Yes. Yes. Okay. Now, I want to talk about something so address what Sylvia asked. If you want to create your customized feature, how you are going to do it? So let's just reload this script. So for now you have a script like that, and if I say okay, I want to use a perspective camera, for instance, and then I don't want to use perspective camera. This is a perspective camera which has like a scale according to camera. But if I want to, for example, switch to orthographic camera, and I don't have that script written down, how can you create your own? And this is a very nice thing in Blender that if you go to the top, on the right, you have a scripting button. You click it, you go to the scripting UI. And on the right, it's a blank because it doesn't know like what you want to see. But for instance, if you want to adjust the camera, what you want is to look at the 3D view of your scene, right? And then for instance, if I want to change to orthographic camera, if you want to generate your own scripts, the first thing you need to know is you need to know how to achieve this in the UI, because the scripting is nothing fancy. Just like if you click this button, it corresponds to a specific command in the scripting. You just copy that script in your script, and you will click that button in the script. So basically, just like every step corresponds to a line in your script. Then you just need to like sequentially tile up those lines, and you'll be able to make your own Python script. So if I click the camera, first I already know how to change it to orthographic camera in the UI. Basically, what you need to do is just click the camera and go to on the bottom right, and then here is a type perspective or orthographic. And if you change it to orthographic, okay, then this becomes orthographic camera. And if you look at, oh, this is orthographic camera, and you will see something magical here is that on your on your bottom left, there's a small window here. There's a small gray window here. Basically, this is history of the script, like correspond to what you did in the UI. So basically what I did, you can see that Blender, context, object, data type, author. And this is basically the command to make camera from the perspective camera to orthographic camera. So what you need to do is just copy this line and then go back to your script. For example, when you initialize the camera, set it to orthographic. That's what I did, right? That's just copy and paste here. And if you guys run that script again, and you reload the script, you'll see that this is orthographic camera. So if you want any customized feature, you just need to look at some online tutorial to see, okay, how can I do an UI? And just go to the scripting interface and then do whatever you adjust, like that and like that. And you'll just copy paste those comments into your scripts and create your own function, and you are able to do this. So, and basically that's all the scripts come from. So for example, let's just open an example. If I want to set up the camera, what I did just open the camera in the UI and I say, okay, this corresponds to BYOPS, blah, 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 blah. And that's basically how those scripts are overbuilt. And any questions so far? No? Okay. And do you guys have any other things you may be curious about? Like I didn't cover? No? Okay, then another thing probably just some of my personal preference, like basically follow up what Abhishek have talked about doing things on server. So basically, I will share the script later, but basically if you want to render on server, I write out some very naive script, like the bash script, basically SSH to your server, and then SCP copy all your file to the server, and then render on server, and then take it back. And basically this is quite handy because if you want to render on server, what I did here is that I can just run bash my scripts. And for example, I want to render on the tensor 1, which is like one of the scripts I have, and want to render which image, for example, the tutorial.py. Let me first uncomment this render image. And then if I render that, and then this basically, oh, I have too many files. but basically, this will like upload your file. Okay, sorry, it failed. Because I forgot to set a path. Okay, so the path it needs to set out the path in the server so that it add the right path. Okay, I haven't set out. Sorry, it failed. But basically, that's how you can run on the server. Just run a bash script like that. Basically, SCP all your files to your folder on server, and call the Blender there, and then so it will generate image and then SCP the image back. And this is how I render on server, and this is, to me, I feel that this is useful. And this is also something even more useful is that I can also have some like the render all, and basically just render all your script here. And then if, for example, if you want to render all the images in your paper, and then you just update the, okay, this is the story I had with Alec once. So when I create this one of my project, I first do a bunch of rendering, and it's nice, it's beautiful, I like it. Like, I think 2 weeks before the deadline, Alex said, hey, I feel like your shadow is too dark. Can you make it brighter? And I was like, what? I need to render everything again? But at the end, I still did it because it is easy if you have this like render all script. Basically, it's just call all your script and then just adjust the shadow brightness and make it brighter, and then run the render all, and then go to bed. And then when you wake up, every image will get updated, and you can easily update. For example, making every shadow brighter in your paper. So that's also I found it.
So you do the compositing in the LaTeX, or you use Illustrator, or?
Oh
like,
yes, in the Photoshop or Illustrator.
So you still need to compose all the images.
Yes, because right now I render every mesh individually. If I want to put 2 meshes in I'll still use Illustrator. Oh, and then Sylvia also asked about the compositing. Okay, to be honest, I forgot where it is. It's probably here. Oh,
There's a
here, and then
thing that says composite.
yes, the world.
Like if you want to have 2 objects in the same scene. That's what you mean.
No, I asked him about the threshold. For the
Yes,
shadow.
yes. Oh, it's compositing button here. So this is where it is. So if you go to the compositing part button, there's like a threshold of the
Right.
of this. Then basically that's a threshold. Yes, that's to answer your
So
question.
there won't be what that threshold is doing,
So if okay,
making everything that is below that white.
completely white. Yes,
That
and it will create a smooth transition. So you don't.
it will create a smooth thing. Okay, that was my question.
Yes.
So don't have like a borderline
Right.
when you put it in the paper. Right?
Yeah, then we won't have border. Yes.
Thank you.
Nice.
Okay. And any other questions? No. Let me see whether there's some camera path. Oh, camera path is something that I create. So similar to what this may point out. If I want to render a mesh in the animation, like render different views, you can also look at the demo camera path. Is there a camera path? Oh, circle camera. Basically, this script basically creates a camera path that's surrounding some look at like 0.5, and you basically will take pictures surrounding that position, and for how many, for example, 10 degrees at a time, then take a picture, and you can set it 1 degree, take a picture, then it will take many pictures. And for viewers, I forgot number of frames. Sorry, this is number of frames. So 10 means that 36 degrees and take a picture, and you need to switch the render image to render animation, then it will render all the pictures taken by the camera's path. And also one last advanced thing. Oh, create your own stream, we already covered this. Okay, that's all of it. Any question or any? Yes.
So I was wondering what the best practices are for doing like animations where the mesh moves. So I have a way that I do this, but it's horrendous. Like I use like on OBJ for every frame, and then like, I have a script that replays them. Which just sucks because you end up with like 25 gigabytes worth of data. So do you have like a clever way of doing this?
No. Currently, if I want to render animation, I will still export all the OBJ file and then do it. But if you want to make it faster, if you just want to update the vertex positions, because this is a Python script, so if you can, so in Blender, I know it's like bpy.context.data.meshes. Yeah, if you can update the vertex positions using like standard Python, like NumPy or SciPy, and then you will be able to render those meshes without the need of saving it. But to me, because I didn't use Python to code up a lot of geometry processing things, so I probably use MATLAB to export all the OBJ file and just render them all. So one example is that if I go to the cubic stylization, like the video. And if we want to render, for example, ship, basically I have all the ship for different iteration. And then I have one script here, basically do a for loop. All the meshes. That's it. And then so I get every image out of it, out of the mesh sequence. But that's still that's what I did.
The best we had so far.
Yeah. Okay. If you have any clever solution, let me know.
No, that's fine. I'm glad I was using clever
Something like that.
Okay.
The alternative is you invent your own like OBJ like video format. You do some like shape differential encoding. Don't do it.
Oh, I mean, you can
Well, let's-
save just the vertex positions instead of the whole
Yeah.
OBJ.
Yeah.
And there was this thing,
Yeah.
I mean, like, at one point one of the students here was using this file format Alembic, which is meant to store moving data. I mean, text file is always the easiest thing.
I think Alembic is pretty standard, no? I mean, people-
Yeah, so I was just wondering that.
Okay.
I'm gonna try it.
But does Blender have some sort of
Use it, but never in core. Just
user-defined properties that you can kind of
It
add?
does say
Oh, that's not
Does Blender have some sort of user-defined properties that you can add on top of the mesh?
like
Like you could
vertex
add,
normal or
like, you know, like animation data.
oh
So you could,
those? I know Blender has a very powerful thing called the animation node.
uh,
Probably that's the way you go, but I'm not familiar with that animation node. But I know that some artists create, for example, some balls flying around the mesh. They are not creating every sequence of the mesh. They use animation node to basically move the ball and then the rendering thing.
so that would be.
So I see my script is not using the GPU at all. It's only
Yeah.
using the CPU. General.
Okay, so the script is not using GPU because that's part of it. Okay, everyone, so this is something important. If you want to set up the Blender, basically the server is okay, but on your desktop, if you found that when you run a script, the Blender is not using GPU, and you need to go to I have a, this is, you need to set up once. You need to basically, so here, preference system cycle render device.
I did that, man.
You did
I
that?
did that, yeah.
Oh, you're still not using it?
Yeah.
Did you save it?
Is there a save button? I thought it just saves it.
Where's the Blender? Wait, where's the Blender preference?
Edit.
Oh, edit?
Edit.
Oh, edit. Thank you.
No,
And
I
then-
have auto save preferences, so I think it should.
And where's the cycle? Hey, I forgot. Where's that? Okay. Oh, system. Preference system. And there's some cycle render device, and you use CUDA, the GPU, and you need to save it. Yeah, save the preference here.
Yeah.
And once you do it once, then it will automatically use GPU render in the future.
How
So-
does this work on the server, Derek? Like if you
I already
yeah, like if you can't decode that in the script, so you have to like if you render on the server, you have to open Blender on
our
server and set the GPU flag.
So yes, for all the thing that has RTX server, I already set it up. So
Okay.
if you render on server, you will automatically use GPU if you use those ones with RTX. But other than that, I don't know I don't know how to automatically set it up in the script. If I figure it out, I'll definitely update that. But I don't know the solution right now.
If it's set it and forget it, that's fine.
Mine is not
Putting
using
that
this.
down.
You're still not using your GPU? Okay, we
Do you
can
have a
figure that out
GPU
later.
on your computer?
I do, yeah.
Do you?
That's the point of this computer.
Okay. So, any questions? No?
Thank you.
Okay.
Thank you very much.
Thank you.
And you'll put the slides.
Yes.
Thank you.
One little tip. If ever you're
Yes.
wanting to render something out that you plan to print, or like, if you're like not sure how large to make a file, the rule, if you think in inches, is 300 pixels per inch. But in centimeters, that's about 120 centimeters, or 120 pixels per centimeter. And so generally, going larger than that, if you're printing it on paper, is pointless because your eyes can't
Oh, yes.
discern. But that's just like if you're ever like, you know, just punching in like 5,000 pixels for something that you're going to print really small, like that's overkill. But for, like you said, for PDFs, it's like you can just zoom in as much as you want. So
Yeah.
anyway,
Okay.
kind of arbitrary.
I don't know how to calculate this resolution. Well, usually I just try
Yeah.
it until large enough I'm satisfied.
And
Yeah.
your PDF ends up being like 600 megabytes.
Yeah, my PDF usually for paper is like 100 megabytes.
100.
Right.
After
But if
compress.
you consider a paper, which is usually like your standard sheet of paper,
Then
and that's 2 columns, it's like most likely not going to need to be more than
300 PBR.
3, yeah, which would be like 900 pixels for like a square.
Yeah.
So that's like just the way this sort of measures.
Yes.
But for web, if you want to just like go nuts and have a nice image you can really zoom into, then the sky's the limit. It's as much as your hard drive can store.
The reviewer's hard drive.
Oh, by the way, feel free to add as scripts you want and to the toolbox. It's
Cool.
yeah. If you have new nice functions, I'll be happy to have it here.
Very, very nice.
Yeah, nice. Handy.
We set up something like this for Maya, for rendering for the fluid simulation paper. So
Oh, is it a set render of Maya?
yeah, we render it for Maya and we set up scripting and everything, and we transfer the height fields, and then we move the vector to Maya in order to generate the model and then set up the material. But it was super painful.
Wow. So it's easier to Blender or use the coding?
It was like because of Blender was
I see.
areas from Maya. But it was so painful. I think I walked like for 2 weeks just generating the shading. There's no community.
Yeah, there's a big community for Blender, but not a big community.
Exactly. There was no class. And now we're not using it. Do you mind if I like share it?
No problem. Like, it's also the open public repo, so yeah. Hopefully it's kind of useful. But this is useful for me, but I don't know. I feel bad if I kind of talk about like selling this around, like basically kind of forcing everyone to use it. But probably this
It
just
makes lots of sense because we have to have some sort of scripting because we keep telling people, yeah, just render this simply. And also the other thing I want to try is
a lot of like simulation paper are rendered.
yeah.
But I never use Houdini, so I don't know.
Albert Chiang and Peter Schroeder's did that.
Yeah.
I'm really happy with Houdini, so I'll try that.
Is it okay? Probably in the interface, or is Houdini has scripting?
No, he's scripting. So the actual code.
It was hard to read.
That would be cool.
So I need to see how that. Because this solves that.
Yeah.
Yes.
If you have more than one mesh, all this transfer thing.
Like, I spent a weekend trying to find something.
Okay.
Realized I didn't
Thank you.
understand American analysis tree, but built it for a time, and then I did something in that.
Well, first of all, like, the minute you find yourself reading like the map, you find it like research. So because like they never actually tell you what the basis function is. So, first of all, like imagine you have
The whole?
like a
Do I need to turn it
Like
off?
okay.
Yeah, just do a stop on
Sure.
stop. Yeah.